Hi students, this is the 8th problem of in this unit. The problem is a simply supported beam of span 8 meter carries 3-point loads of 10 kN, 5 kN and 8 kN at 2 meter, 4 meter and 7 meter respectively from the left support. Determine the reaction for the supports. Here, what should we find from the problem? We should find the reaction at the support. Okay, for the simply supported beam analysis or what it may be, actually first of all we should find the support reaction, how much force it will carry at the support. Okay, okay, here in this problem they give all detail in this problem very clearly. The span of this beam span is 8 meter, total 8 meter. 2 plus 2 4, 4 plus 7 1 equal 8, total 8 meter, and it carries 3-point loads. Okay, so first point load is 10 kN, second point load is 5 kN, third point load is 8 kN, which is acting from where? Okay, from the left support. Here's the left support, this is the right support. They mention clearly in this problem the forces are acting from the left support. How far from this left support? So first load is acting 2 meter away from the support, 2 meter. Second load is 4 meter from the left support. Third load is 7 meter from the left support. Okay, here they mention clearly 10 kN, 2 meter from the left support, 5 kN, 4 meter and 8 kN from the 7 meter from the left support. Okay, what should we find? We should find the reaction at the support. What reaction means? RA. What is RA? Here RB. What is the RB? That means reaction at the support. Actually, how can we work out this problem? Okay, actually for the equilibrium condition, summation of upward force equal to summation of downward force. So we can also write like this: RA plus RB. This is upward force. There are two upward forces. Okay, RA as well as RB are the upward forces. Okay, so how many numbers of downward forces are there? 1 2 3 3 numbers of downward forces there, right? What are they? 10 plus 5 plus 8. Okay, so RA plus RB equal to 23 kN. We don't know exactly how much force is carrying this load at the support A, how much amount of force is carrying at the support B. Here we should find the forces. Okay, this is the keep like equation number 1. Then what's the next step? First of all, taking moment about A. Okay, what should we do? We should take the moment at the support A. Okay, how will you take the moment? Here you put your finger over at this joint. Okay, put your finger like this, and you should take remaining force moment. Okay, how will you take the moment? Moment means moment equal to force into perpendicular distance. Keep in mind, force into perpendicular distance, not the distance. Okay, so how will you take the moment? Here one upward force is there. Okay, one more time I remind this unit conversion. Sorry, when the force is acting towards the upward direction, you should take positive sign. When the force is acting towards the downward sign, you should consider as a negative. Okay, don't forget to keep in your mind. So here we are going to apply the same principles in this problem. Here RB is acting towards the upward direction, so RB is the positive. RB into what is the perpendicular distance? This is the direction of line of force, right? So what's the distance? This is the distance, right? This is the force, this is the distance. So 2 plus 2 plus 3 plus 1. Okay, 2 4 7 8 meter. Then here one force which is acting towards the downward direction, so this is the direction of force, right? here this is the distance, perpendicular distance, so you can put negative sign. 8 into 2 plus 2 plus 3, so 7 meter. Again one more force is there, so which is acting towards the downward direction, that is a 5 kilonewton. Okay, so which is acting to, that's why we put the negative sign. So 5 into 4 meter. Here one more problem is there, which is also acting downward direction. 10 into 2 meter, that is equal to 0. So just resolve this equation. The 8 RB minus 96 equal to 0. Clear? So 8 RB equal to 96. RB equal to 96 divided by 8. So when you solve this time, you will get the value of RB 12 kilonewton. Okay, this is the reaction at the support B. So RB equal to 12 kilonewton. Then how can we find the reaction at the support A? So already we know, right? This just substitute RB value in equation 1. What's the first equation? RA plus RB equal to 23 kilonewton. So RA, you don't know the RA value, but you know the RB value, 12 equal to 23 kilonewton. So RA equal to 23 minus 12. So RA equal to 11 kilonewton. So RA plus RB equal to, that's a 23. Okay, that's 11 kilonewton. That's a check. If you add these both things, that means RA plus RB equal to 23. The support force equal to downward force. Downward force also 23 kilonewton. Okay, the condition is satisfied. This is a simple problem. Okay, then we are going to work out one more problem. Actually, this is the next problem. What's the problem? Read the problem very carefully. Find the reaction at the support A and B as shown in figure. This is a simply supported beam. Here 2 point loads are acting on this member. So how far from this point A? So 380, this 1000 Newton which is acting 3 meter away from the point A, and this 400 Newton which is acting 1.5 meter from the right side support. Okay, from the right side support. Here we should find the RA and RB. What is the RA and RB of this beam? Okay, how can we work out it? As usual procedure, we know the condition, right? Upward force equal to, you can also write like this: upward force equal to downward force. So upward force is RA plus RB equal to downward force 1000 plus 400. So RA plus RB equal to 1400 Newton. You can keep, this is the equation number 1. Then what will you do? Take moment about A. Here two things better to keep in our mind. First one is sign conversion. Upward force is, you should consider as a positive. Downward force you should consider negative sign. And second thing is, what is the moment for formula? Force or load into perpendicular distance. Okay, these two things but better to keep in our mind. Okay, very important. So similarly you can do the same things. You put your finger over here. This is a RB, right? RB which is acting towards the upward direction. RB into, what's the distance? It's a 6 meter. 3 plus 1.5 plus 1. That's a 6 meter. Here one downward force is acting, so you can put the negative sign. 400 into, what's the distance? Perpendicular distance. This is the line of action. This is the distance. So 4.5, better to put in a bracket. Okay, second one more force is there, the 1000 Newton into, what's the perpendicular distance? 3 meter. 1000 into 3 meter. Okay, equal to 0. So 6 RB minus 4800 equal to 0. 6 RB equal to 4800. RB equal to 4800 divided by 6. Clear? So what's the value of RB equal to 800 Newton? Just you find the value of RB. Then after that, substitute RB value in equation 1. So RA plus RB equal to how much? 1400 Newton. Here you know the RB value, right? Just 800 equal to 1400. So RA equal to 1400 minus 800. So RA equal to 600 Newton. Clear? Just we find the value of RA equal to 600 Newton. This value is 800 Newton. Clear? And thank you for watching this video.